A very good morning, students. Today we'll be learning about Indian monsoons. Monsoons are a complex meteorological phenomena. Experts of meteorology have developed a number of concepts about the origin of monsoons. In today's class, we'll learn about the concept of origin of monsoons, burst of monsoon, break in the monsoon, onset of monsoon, progress of monsoon, rainfall distribution, variability of rainfall, and the climatic regions in India. The thermal concept of Halley. Halley, a noted astronomer in 1686, hypothesized that the primary cause of the annual cycle of Indian monsoon circulation was the differential heating effects of land and the sea. According to this concept, monsoons are the extended land breeze and sea breeze on a large scale produced by the differential heating of the continents and the ocean basins. During the summer season in the northern hemisphere, when the sun's rays are vertical over the Tropic of Cancer, the huge landmass of Asia gets heated quickly and develops a strong low pressure center near Lake Baikal in Siberia and Peshawar in Pakistan. This thermal low extends up to 700 millibar. Moreover, the poleward shift of the intertropical convergence zone to a position over southern Asia reinforces a thermally induced low pressure center. Under the extreme low pressure condition on land, the wind from the southern part of the Indian Ocean is attracted towards the subcontinent of India. The air coming from the oceans towards the land is warm and moist. When land barriers like mountain ranges and plateaus come in the way of moisture-laden winds, they ascend and result into saturation, condensation, and precipitation. As compared to these high pressures, the Indian Ocean and the Pacific Ocean remain relatively warm, having low pressure areas. Consequently, there is an outflow of air from the high pressure of the land to the low pressure areas of the oceans. The air blowing from the high pressure areas of the land towards the sea is cold and dry. This cold and dry air is incapable of giving precipitation unless it comes into contact with some water body, ocean or sea. The thermal concept about the origin of monsoon has, however, not been accepted universally, as it fails to explain the intricacies of monsoon. Besides differential heating, the origin and development of monsoon are also influenced by the shape of the continents, orography, and the conditions of the air circulation in the upper troposphere. The low pressure areas that develop over the continents during the summer season in the northern hemisphere are not stationary. The other critique happens to be these low pressure areas change their position suddenly. This sudden change in the low pressure areas are not exclusively related to low thermal conditions. The low pressure area stabilizes in June in the northeastern parts of the subcontinent. In fact, they represent the cyclonic lows associated with the dynamic factors, and therefore these low pressure areas cannot be termed as only thermally induced. Had the monsoon been thermally induced, there would have been anti-monsoon circulation in the upper air of the troposphere, which is lacking. Halley did not take into consideration the Coriolis effect of rotation of the earth on its axis. On a rotating earth, the wind has a tendency to move towards its right in the northern hemisphere and towards its left in the southern hemisphere. The role of the latent heat passing into the atmosphere through water vapor was also not considered by Halley. Water vapor also plays an important role in the origin and development of the monsoons. The next concept of the origin of monsoons is the dynamic concept by Flown. The dynamic concept about the origin of monsoon was put forward by Flown in 1951. According to this concept, monsoon is the result of seasonal migration of planetary winds and pressure belts. The intertropical convergence zone is formed due to the convergence of northeast and southeast trade winds near the equator. The northern and the southern boundaries of ITCZ are called the northern intertropical convergence and southern intertropical convergence respectively. There is a belt of doldrums within the intertropical convergence zone characterized by equatorial westerlies. At the time of the summer solstice, which is on 21st June, when the sun's rays are vertical over the Tropic of Cancer, the northern intertropical convergence is extended up to 30° north latitude, covering South and Southeast Asia. Thus, equatorial westerlies are established over these areas. The equatorial westerlies become southwest or southern summer monsoons. On a rotating earth, the trade winds of the southern hemisphere after crossing the equator turn towards their right because of the Coriolis effect. the north intertropical convergence is associated with numerous atmospheric storms which yield heavy rainfall during the wet monsoon months, which is from July to September. Similarly, the northeast or the winter monsoon does not originate only due to the low pressure in the southern hemisphere during the winter solstice, which is when the sun's rays are vertically over the Tropic of Capricorn. In fact, the northeast monsoons are northeast trade winds which are re-established over Southeast Asia due to the southward shifting of pressure and wind belts. It is obvious that due to southward movement of the sun at the time of the winter solstice, the northern intertropical convergence is withdrawn from over the South and Southeast Asia, and northeast trade winds occupy their normal position. These northeast trades thus become winter monsoons. The northeast monsoons having their origin on land are generally dry and devoid of the rains. Now, let's look at some of the recent concepts about the origin of Indian monsoons. During the last 5 decades, the upper atmospheric circulation has been studied significantly, as a result of which meteorologists have raised certain doubts about the validity of the classical concept of origin of the Indian monsoon. It is now believed that the differential heating of land and sea cannot produce the monsoon circulation. More recent theories have laid greater emphasis on the circulation and atmosphere over the subcontinent and the adjoining areas. Apart from the upper atmospheric circulation, recent concepts rely heavily on the role of the Tibetan Plateau, jet streams, and the El Niño Southern Oscillation. The data gathered by meteorologists after the Second World War have revealed that the origin and mechanism of monsoons are related to the role of the Himalayas and the Tibetan Plateau as a physical barrier and a source of high level heat, and also the circulation of the upper air jet streams in the troposphere, and the existence of upper air circumpolar whirl over north and south poles in the troposphere, and the occurrence of El Niño in the South Pacific and the Indian Oceans. Now let's look at Indian monsoons and the Tibetan Plateau and their interrelationship. In 1973, the monsoon expedition, or the MONEX, was organized as a joint venture of Soviet Union and India. Under this expedition, 4 Russian and 2 Indian ships equipped with modern scientific instruments were passed into service in the Indian Ocean and the Arabian Sea to investigate the phenomena of the Indian monsoons. The period of investigation extended from the month of May to July 1973. On the basis of the data obtained, the Soviet meteorologists arrived at the conclusion that the Tibetan Plateau plays a crucial role in initiating the monsoon circulation over the Indian subcontinent. While participating in the International Symposium on the Monsoons of the World, had expressed views that the summertime heating of the plateau of Tibet was the most important factor in the causation and maintenance of monsoonal circulation. The Indian as well as the Soviet scientists were unanimous in their views on this point. The plateau of Tibet is 600 kilometers wide in the west and 1000 kilometers in the east. Its length from west to east is about 2000 kilometers. The average height of the plateau is about 4000 meters. Thus, it is an enormous block of high ground acting as a formidable barrier. It is also one of the most important geographical controls on the general atmospheric circulation in the region. The plateau of Tibet affects the atmosphere in 2 ways, acting separately or in combination of as a physical barrier and as a high-level heat source. The summertime heating of the Tibetan Plateau makes it a high-level heat source. This heat engine produces a thermal anticyclone over this region. A warm core anticyclone is formed over the plateau during the summer monsoon period. The formation of this anticyclone takes place in the middle part of the troposphere at 500 millibar level. It is the result of a process called anticyclonogenesis. The anticyclone at 500 millibar at Tibet weakens the western subtropical jet stream south of the Himalayas, but produces tropical easterly jet on the southern side of the anticyclone. This tropical easterly jet stream first develops in longitudes east of India and then extends westwards across India and the Arabian Sea to eastern Africa. Blowing along Kolkata-Bangalore axis, the air under the easterly jet descends over the Indian Ocean near Mascarenes and the Zanzibar Islands of Tanzania and intensifies its high pressure cell so as to finally move as southwest monsoon. Now let's move on to the next concept for today, the burst of monsoon. The suddenness and the abruptness of the Indian monsoon is known as the burst of monsoon. It always accompanied by turbulent weather. This so-called burst of the monsoon is associated with certain basic changes in the general upper air circulation over southern Asia. In April and May, the insulation heating of the subcontinent tends to establish the southwesterly monsoon flow from the adjacent ocean, but northward surge of the same is retarded by the westerly zonal flow associated with the subtropical jet stream over northern India. However, in late May or early June, when the thermal conditions are satisfied, the jet stream disappears completely from the south of the Himalayas and shifts to a position to the north of Himalayas and Tibet. At the same time, the upper trough low at the low pressure also moves westward from 85° east to 75° east. It may be pointed out that the jet stream does not retreat slowly. The process of this shift is rather quick. Now, with the disappearance of the jet, a definite monsoon circulation from the sea on the land is established. The summer monsoon generally begins in late May in most parts of Southeast Asia, but over India it is delayed until the middle or late June. It is well to remember that the onset of monsoon occurs in several stages depending on the periodic advance and withdrawal of the equatorial convergence zone. In opinion of Koteshwaram, the burst of monsoon is closely related to the development of a warm core upper anticyclone over the extensive and lofty Tibetan highland. The upper level anticyclone produces an easterly jet over India, which is positioned at about 15° north. It is definitely a part of readjustment in the general planetary circulation pattern. Gradually, the easterly jet covers the entire region extending from India to East Africa. The above mentioned upper air condition paves the way for an advance of southwesterly monsoon current over the subcontinent. The monsoon current therefore prevails throughout India. The depth of the monsoon in India is about 6.5 kilometers, while over Gangetic Plain it is only about 5 kilometers. The relative humidity increases in the atmosphere tremendously. The arrival of monsoon is also the beginning of agricultural operations for the kharif crops in the rain-fed areas. The high temperature and high relative humidity are, however, oppressive and injurious to health. Breaks in the monsoon. The migration of the monsoon rainfall zone is one of the major sub-seasonal variations of the summer monsoon. Thus, the monsoon is not a continual deluge of number of months duration, but has inter-seasonal variability, being made of series of discrete events, both pluvial and dry. Viewed locally, these are the active and break monsoons respectively, which exist on a time scale ranging from a few days to few weeks. Thus, while the monsoon appears to have well-defined annual cycle, closer examination shows that the monsoon has substantial variability, which becomes evident as the intensity of monsoon rains wax and wane through the wet season. Periods during which there is a rapid succession of weather disturbances or storms lasting a few days are referred to as active periods of monsoon. Periods during which there is no rainfall for a few days are the break periods of the monsoon. During an active phase, the tropical easterly jet stream remains very strong in the upper troposphere, indicating strong convection and latent heating. But when the maximum cloudiness remains locked up in the foothills of Himalayas and the monsoon rainfall zone moves in this direction, subsidence occurs to produce a weak easterly flow in the upper troposphere. Cloudiness decreases and the southeasterlies at the surface levels over northern India are replaced by hot westerly air which blows over the plains, since the broad scale surface pressure shifts to the Himalayas and the rainfall practically ceases over the country outside the Himalayan regions and the southern slopes of the Himalayas, leading to high floods in the plains of these Himalayan rivers. Thus, though there is no rain over the plains, all the major northern and eastern Indian rivers rise and flood ensue. Under weak monsoon conditions and in the years when the eastern end of the axis of the monsoon trough is oriented southward in Odisha, Jharkhand, Chhattisgarh and Madhya Pradesh, a low valley trough develops over the Assam plain aligned along the river Brahmaputra between the eastern Himalayas and the Shillong Plateau. The vertical extent of this low valley trough is 2 to 3 kilometers, with the southwest monsoon lying to the south of the trough, remaining independent of the main monsoon trough. But when the latter moves northwards and extends to the Himalayas, it joins the trough over the Assam plain to cause heavy rainfall there. Onset of the monsoon. The onset of the monsoon rains is viewed in monsoon literature as the burst of the monsoon, commonly in the form of great thunderstorm. Prediction of the onset of the monsoon helps farmers to select the most suitable crops to sow and to determine when to prepare the land. Predicting the timing of the monsoon has been an onerous task for the Indian Meteorological Department almost from its beginning. Since 1878, forecasts of the monsoon rainfall has been issued by the department regularly. Now let's look at the progress of the monsoons. The normal date of the onset of the monsoon is towards the end of May in Sri Lanka and over Andaman and Nicobar Islands and Bay of Bengal. Thereafter it bursts on the Malabar coast in Kerala a week later by June 1st. And the ISO lines on the onset chart display a pronounced curve over Bay of Bengal. The subsequent progress of the monsoon in the country is divided by tapering peninsula into two bifurcating currents, the Bay of Bengal current and the Arabian Sea current. The Arabian Sea branch gradually advances northwards, reaching Mumbai by 10th June and central India by 15th June. In the meantime, the progress of the Bay of Bengal branch is no less spectacular. It rapidly strikes the Arkan coast and Chittagong hills with full force, the direction being southwesterly, but the greatest force is felt in the angle between east-west Meghalaya plateau of the Kashi hills and the northeast Lushai hills in Mizoram. Here, Mawsynram to the west of Cherrapunji at an elevation of about 1313 meters receives nearly 1200 centimeters of rainfall annually. The Brahmaputra valley is in the rain shadow of the Kashi hills and receives less than 250 centimeters. The rainfall increases once again in the Himalayas, but the Bay of Bengal monsoon branch is deflected westwards due to the combined effect of monsoon trough and the channeling by the Himalaya. As a consequence, its further progress is towards the Gangetic plain of India, giving more rain to Himalaya and less in the plains. The arrival of the monsoon over Kolkata is 7th of June, where, as mentioned earlier, the Arabian Sea branch of monsoon normally strikes Mumbai on 10th June. Both the branches of the monsoon current merge in the Gangetic plain and gradually extend over Bihar, Jharkhand, Chhattisgarh, Madhya Pradesh, Uttar Pradesh, Uttarakhand, Haryana, Himachal Pradesh, Punjab, Jammu and Kashmir, and finally to Rajasthan, so that by the first week of July, that is within a mean interval of 29 days since the onset in Kerala, the southwest monsoon is established all over India, excluding the Thar Desert. In the Thar Desert, the monsoon reaches by the middle of July, but only as a descending drying wind, since by this time it has almost shed most of its moisture. It can be noted from the figure that for parts of the country west of 80° east and south of 25° north, the advance of monsoon is from the south to north, while in the rest of the country it is from southeast to northwest. Rainfall distribution. The distribution of rainfall in India is highly uneven. Its distribution is largely controlled by the nearness of the sea and the orographic features. The influence of the Western Ghats, the plateau of Meghalaya, the northeastern hills and the Himalayan mountain is quite significant. It may be observed from the figure that the regional variations in the distribution of annual average rainfall over India are quite pronounced. In the southern parts of Meghalaya plateau, the Mawsynram and Cherrapunji, the average annual rainfall is more than 1200 centimeters. However, it drops down to 200 centimeters or less in the Brahmaputra valley adjoining the hills. In peninsular India, the highest rainfall occurs along the Konkan and the Malabar coasts. The ISO height of 150 centimeter rainfall runs southwards from the Gujarat coast, roughly parallel to the crest of Western Ghats up to Kanyakumari. In northern India, it includes the hills of Himachal Pradesh, Uttarakhand, Chhattisgarh, eastern Maharashtra and northern Andhra Pradesh. Now let's look at the variability of the rainfall. The rainfall in India is highly variable. The actual rainfall of a place in a year deviates from its average rainfall by 10 to over 60%. The highest variability is found in the areas where the average annual rainfall is the lowest. For example, the desert areas of Barmer, Ganganagar, Jaisalmer, Jodhpur, etc. have less than 20 centimeters of average annual rainfall. In these areas, the variability of rainfall is around 60%. Contrary to this, in the areas where the average annual rainfall is over 200 centimeters, in Mausendram, Cherrapunji, the annual variability of rainfall is less than 10%. The western slopes of the Western Ghats, the lesser Himalayas, the Shivaliks and the Tarai belt also record between 100 to 200 centimeters of average annual rainfall. The variability of rainfall has a significant role in the agricultural operations and other economic activities of the country. The areas showing high variability of rainfall have chronic deficiency of water. Such regions are highly prone to droughts, floods, famines, while the areas with high average annual rainfall are less affected by droughts. Though flood is a regular feature in the flood-prone areas. Now let's look at the climatic regions of India. India is often referred to as a country with tropical monsoon type of climate. The large size of India, its latitudinal extent, the presence of Himalayas in the north and the Indian Ocean, Arabian Sea and Bay of Bengal in the south have resulted in great variations in the distribution of temperature and precipitation in the subcontinent of India. A number of attempts have been made by climatologists, geographers and experts of agriculture to divide India into climatic regions. While some of these classifications have been suggested by world climates, others are exclusively applied to Indian conditions. A systematic study of the climatic divisions of India was attempted for the first time by H.E. Blandford, the first Director General of IMD in 1889, who discovered that all types of climates found in the world are present within the subcontinent of India. This classification on temperature and rainfall of a few selected stations of India was almost an overgeneralization. Indian monsoon is a complex yet easy to understand phenomena. Despite the regional diversities in climatic conditions, it is obvious from the above description that there exists a climatic unity in India. The climatic unity means that weather conditions over different parts of India are more or less the same during different seasons round the year, leaving minor variations as exceptions to the rule. Indian climate is called monsoon climate. India is a country of climatic diversities which are expressed in the variations in the distribution of temperature, pressure, winds and amount of precipitation. The factors which are responsible for determining the climate of different regions of India include her location, latitudinal extent, physiography, role of the Himalayan ranges, climatic divide, monsoon winds, upper air circulation, western disturbances and cyclonic storms. Derived from Arabic word mausam, monsoon implies the rhythm of season and seasonal reversal of the winds. Meteorologically, the year in India is divided into 4 seasons, namely the cold weather season, hot weather season, advancing southwest monsoon season and the retreating southwest monsoon season. These seasons have different characteristics of weather conditions.